And I was saying I'll record, but doing the usual spiel. If you would not like to be recorded, you may mute yourself, turn off video, leave, kind of whatever is most appropriate for your situation. And I need to share my screen. Okay, see what we've got today. All right. Okay. So yeah, this is probably relatively light today. After 2.4, we've been kind of turning a lot of the Loki team's efforts in different places, and so there's not a ton of updates here. But I think we can probably start off with Steve, who's aggregating Loki rules into a single config map and
Sorry,
reloading
Steve,
rules.
I don't mean to throw you on the spot, but you were the first to add it to the agenda, so I left it at the top. I think I saw Steve join.
Is Steve here?
Sorry, I was on mute.
Oh, no worries.
That's fine. I'm just looking for my notes on what I sent. Apologies.
No problem. Do you want us to circle back around in a few minutes?
No, it's fine. I was trying to look at the name of the sidecar piece, but fundamentally, Loki, brilliant. 2.4 has made a massive difference, and I was speaking to Jen about some of the potential improvements, and we build Kubernetes as a platform, so we stick Loki in each of our clusters for nice localized logging. Nice. The current design means that we need to know all of our Loki rules when we build the cluster, rather than like the Prometheus model where we can add rules dynamically. So the initial question was whether there was any intention for putting a Loki operator in with a custom CRD. And then the follow-up question was, actually, I can see a pattern to use a config map generator as a sidecar. Whether anyone had looked at that, and if they hadn't, I'm happy to have a look at it. But also, whether there's an endpoint in Loki to reload the rule component, and generally just sort of see if anyone else has been speaking about this previously.
Yeah. Cortex tool. Let's see. I got kind of a couple answers we can start with, and then we'll move on to the more complex answer of operator and CRD. But there are rules. Yeah, so we implement a lot of the same endpoints that Prometheus itself actually does, and you can configure Loki to use a backend which is dynamically reloaded, and you can also put stuff against it, get, delete, kind of all your normal CRUD methods. And this,
it's more whether you can reload Loki. So there's I forget the exact name of the sidecar, it's a Kiwi Grid sidecar that watches config maps of a specific specification, merges them into a single config map, which would obviously be a known value that could be mounted into the Loki rule pod, but the output of that action changing the config map is a webhook, and it's whether Loki has a webhook to reload or whether you need to kill the pod and start it again.
Okay. So this particular model would need to be reloaded. The whole process would need to be reloaded here. Actually, I need to actually double check that off the top of my head. We might hook into the same code. Like if you change the file on disks, will Loki reload
Thanos has an endpoint, so I was wondering if you had the same similar principle. Thanos rule obviously can be fed and then has that endpoint to reload the process.
We certainly don't function equivalently. Loki has a number of back-end stores. I know this isn't exactly what you're asking, but just want to throw it out there. Loki has a number of like configurable backend stores that you can use. For instance, like we run a lot with like a GCS bucket as a backend, which means that we can, and that will be dynamically reloaded and also dynamically resharded across a number of rulers so that you can kind of horizontally scale that subservice. For using config maps specifically, I'm not sure off the top of my head if we reload, if that same like reloading code runs on like a local file system as well. My guess would be no, but I'd have to double check there. And then do we offer an endpoint? No, although like the idea of reloading regularly based on the local file system or like mounted config map seems completely reasonable to me, right? Since we already regularly reload things like backend object store buckets for rule configuration, we could do the same thing on localhost, and I wouldn't see a problem there. It also probably wouldn't be too much of a lift in terms of code. So I think we should definitely put that on something I need to validate. I just don't want to go spelunking through the code right now in this call. If anyone else knows,
I'm trying to. I think it maybe does reload. I'm trying to figure out if the file store does it. The others do, but
yeah. So if we can confirm it works, I'm happy to put a PR in on the Loki distributor chart, which is the one that we use. To put an optional sidecar in to scrape config maps together into a single config map. That means that rule can operate similar to Prometheus.
Yeah, it should reload. So if you mount the config map as a file and use it as a local file rule, it looks like we do rescan that periodically. There's a timer that does it. So I don't think there's a webhook, but there's a timer that runs. I'm not sure if that interval is configurable, but it should reload the rules if the config map changes.
Awesome. I'll give it a go.
Do you know what the timer is, Ed?
Let me go back a bit here and see.
Into the whatever that timer is, that would basically turn your delay interval to there's Kubelet has a timer as well for like maximum config map resync interval, and I can't remember exactly what that's called, but it would be that plus whatever our internal timer is would be the maximum lag that you have.
Yeah, it is configurable. It's called the poll interval, and it's
wonderful.
I don't know what the default is. I'm guessing 5 or 10 seconds. Let me see. 1 minute, actually. That's pretty long. So the default poll interval is 1 minute for rules, but that could be, I don't see any reason why that couldn't be 5 or 10 seconds. Although I guess I'm sure there's a trade-off there too with what it does, but yeah, I think that if you load as a config map, that it should auto reload. Let us know how that works though, because seems like a reasonable thing to be able to do if we're not doing it already. It seems like it's most of the code's already there. It should already work, hopefully.
Again, not the specific question that was asked, but this is kind of a nice tie-in. Something that I've wanted to add for a while. Oh, I need to put that as, we've got this new low-hanging fruit tag in the Loki repo that I'm trying to use to bootstrap things of limited scope. We've got some possible to-do work here. We can right now you can tell the ruler to like enable its API or not. So historically, this functioned exactly how Prometheus did, which was you loaded from the file, and that was that. And then initially in Cortex, which is our parent project, the ability to like basically dynamically do this stuff and persist it to like an object storage backend, that sort of thing, was added, and so there's a flag to enable the API. But the file system actually does not have an implementation to support it. But we could definitely enable the API on top of a file system backend, and I've got this request a number of times to be totally reasonable. So on to do.
The Loki operator. So I guess I don't want to spoil the we'll have a better announcement around this once it's sort of in action. But the awesome folks at Red Hat have built a Loki operator that they're using with an OpenShift that's going to be upstreamed into the Loki project for a general Kubernetes operator. So there'll be sort of a lot more to come on this over time in terms of like how it evolves and how it gets used. But it's primarily targeting probably the exact use case that that you're using, Steve, where they basically want to make it easy to provision, relatively, I would say, sort of small, medium-sized Loki cells in an easy fashion. So I guess stay tuned to that. We are going to say we'll be upstreaming it into, they're contributing it to the project. So we're excited about that. So you'll see more about that soon.
Does that all answer any of your questions, Steve?
No, that's brilliant. Thank you very much.
Yeah.
All right, wonderful. Ed, you want to talk about 2.4 a little bit?
I put this on here just to sort of a couple things that we've noticed. I don't know what to do about the first one here. That it has been inconvenient for a lot of folks because we enabled the wall by default, and that directory wasn't mounted in the. So if your config doesn't specify where the wall directory is, it just defaults to a directory named wall, WAL, which isn't going to be mounted by anybody and isn't going to be writable on almost any container. Like our Loki containers, I can't write to that. So that has been a bit frustrating for people. So you basically need to specify the directory, and on the newer configs that we've built that are part of the opinionated configs do this. But if you have an existing like values file for your Helm chart, for example, that has a config in it, it's not going to do this, and you're going to get this error. I think we've merged some PRs to make the error more descriptive to try to improve this, because I know the error is a bit nasty too. It just can't make dir wall, and it doesn't really help you understand what to do. So if you run into that, if you've seen that, it basically means you need to specify in the ingester config where you want the wall to be, and you have to make sure that you have in your container that mounted as writable. Usually people just specify the same container. You put the, BoltTV index files and the perhaps chunks files like /Loki is already writable by the container, all new containers. So you can put it there. But
yeah, can we just make this can we handle this or mitigate this in a Docker image and just make that writable already?
I mean,
part of the construction?
yeah, like the reason we broke it, or what broke, I guess, is because we in code now enabled the wall, and in config, if you don't specify the wall directory, it's so like we could in code force the wall directory to one that we know that works in the Docker image, but I'm not sure if that's a better side effect. It's basically just change the default from wall to /Loki/wall, and that would fix it. But what's annoying about that is that the Helm chart mounts all of the stuff at a different location than the Docker image does. So the Docker image mounts everything at /Loki, but then the Helm chart overrides that to /temp or no /var local or something like that. It's a mess. I don't know how to unmess it, honestly. But it's just the
it's a mess. I don't know how to unmess it. Welcome.
So sorry. I mean, I wish I knew a better way, but we want the wall enabled by default because I think it's a value to everybody. Like they should have it. Unfortunately, defaulting the directory becomes really, really difficult because the Helm chart has different defaults than the JSON, which has different defaults than the image itself. And I don't know how to reconcile that.
Did the Helm chart get updated in the end?
I updated the Helm chart to the default values.yaml file that comes in the Helm chart now specifies the wall directory to match whatever was specified in that particular Helm chart, because it's actually different between the Loki Helm chart and the distributed Helm chart. The rabbit hole gets deeper. So each of those were updated, but typically most people have a values file that they've curated and don't probably go reference to see if the one that ships with the Helm chart changed. And I think that's what caused a lot of the trouble. Is
I think it was missed from the README. There's multiple examples on the distributed chart README, because you don't distribute min.io with the chart. You don't run it in single shipper mode.
It definitely was missed from the README, because I think I made the PRs and I didn't update any README, so I could go look at that.
It took a couple of hours to update to 2.4's config based on the docs, the values in both the non-distributed and distributed charts, and WAL was one of the ones that was potentially missing from the docs. And as you say,
you felt this pain then, Steve, you're saying?
Yeah, we adopted 2.4 the day it was released, so it took me a couple of hours to get it working.
Sorry about that.
What I guess is there something that we could do to help others at this point still, or where did you go look that you didn't find the answer
So
you wanted?
I mean, first principles, if you ship min.io in the distributed chart and ship it with the bulk DB shipper turned on, the config will be closer to what most people should be using, and then you wouldn't need the extra copy and readme. But I think there's some missing continuity in the docs, so then you can read what something does, but the configs obviously are dependent on each other. And, the WAL being a new concept that was introduced, and I saw your commit, but I didn't see it updated in the README or anywhere else, made it slightly trickier, and the fact that the paths were different added to the
I'll also just throw out there, I'm terrible at Helm, and so whenever I'm messing around in the Helm charts, I don't know, I feel like I make it worse than better sometimes, but the README is a good one, though. I should look at that.
And I do think it is reasonable to maybe change the default in the actual binary, because /wall is just never
right.
exist.
Yeah, we could probably change it to be at least right one of the times, but
exactly. Yeah, pick one of the 3 right options and just go with that.
Yeah, this is probably on me, right? I'm almost positive.
If you're after another chart maintainer, I'm happy to help with any of that stuff. We're
absolutely, yeah. The Helm charts, we've always been in a bit of a challenge here because internally we run Loki with JSON, and that effectively makes us the only ones in the world that do that. Everybody largely, that's not true. I mean, there are a lot of people use JSON, but I know we're a bit unique there. So we don't have a lot of hands-on with the Helm charts, and like the Loki distributed chart was very graciously created and donated by the community member, and for the most part, the charts are community maintained. So absolutely would take you up on that if you'd like to be involved with helping with the Helm charts, and helping me understand how to not break them would be nice too. So if you, maybe the best way, Steve, is ping me on the public Slack. Grafana or slack.grafana.com. There's a Loki channel, or just kind of DM me and we can kind of figure out how to get you involved. I would really appreciate that. Yeah.
Sounds great. Thank you.
The other thing that's come out is that we did miss some configs in 2.4 for getting the most parallelism out of Loki. So I'm not sure. So the parallelized shardable queries, I know for a fact, is still defaulted to false, and that's going to be a big one because it's going to enable sharding on shardable queries, which allows them to be split basically 16 times farther. So that's a huge config. Probably it matters more when you have multiple instances running, because if you're only running one instance, parallelization is largely limited by your CPU cores and throughput, but you're going to want that on. We will update this in the next release, so these will get fixed and probably be 2.5 to be basically correct defaults. And I pasted a couple others here. I should have added more notes to these. Maybe I'll circle back around. The split queries by interval one actually confused me because we define that as both a config and a limit, and I'm not sure which one you really need to set, but you want to enable splitting queries. That's the other way we parallelize. 15 minutes is a reasonable default. We actually probably run 30 minutes in some of our clusters too. You can go less than that, but there's diminishing returns on splitting by time because you end up duplicating a lot of work.
I would be hesitant to run 15 minutes, honestly.
Should we just say 30 minutes?
Yeah. I mean, you can run 15, but if you're running like under 30, 40 queries, like I wouldn't hit 15.
Yeah, the sort of way that works, right, is if you think about how much data is in one chunk, and if you tend to, max chunk age is 1 hour or maybe 2 hours, and you don't write a lot of data and you don't end up filling chunks, if you split by 5 minutes, it just means you're going to take that 2-hour chunk and break it up into 5-minute pieces, and every query is going to be operating on the same chunk. It's not really going to be faster. if you have streams that are writing 10 chunks a second or something, that would be a huge amount. But splitting those on 5-minute intervals would effectively parallelize a lot better. I mean, someday Loki will be smarter at this. You know, we'll know the throughput of a stream and be able to split automatically. But for now, it's a bit of a tunable that 30 minutes is probably a pretty reasonable default.
Sorry, my voice again. Can I ask a question?
Yeah, please.
So I said we build and ship Loki as a platform. So we've got some consumers, and we're taking on some new internal consumers on this. It's an internal platform. And one of our consumers turned their chunk age to 24 hours because they read the docs that said unfilled chunks are bad. Now that's running on the distributed chart, so massively distributed. I'm assuming that is a an area where my understanding is an hour to 2 hours on chunk size, chunk age, set the chunk size down. I couldn't find anywhere definitive that pulled that logic together.
Yeah. So where you find yourself is sort of where I would say our kind of maturity as a project lies, right? So there's a lot of tunables, and we've gotten a lot better at tuning them through experience, and haven't gotten very good, I guess, so far at figuring out how to communicate. 2.4 included a number of those sort of opinionated changes that we've learned on how to run Loki for reasonable use cases. Like we, force the chunk target size now and the max chunk age. So this is an area that we want to put more time into. We're trying to get a lot better at to make it easier to just have Loki work. To answer your question specifically about the max chunk age, I probably would advise against doing 24-hour chunks.
that's what I advised against. But
I don't think the optimization that they would get from the information that they read is going to offset the sort of trouble you might have. Like, it's not that big a deal to flush small chunks, but it depends a bit on the storage you're using. And I'll talk about this in a second, maybe if we have time at the end, about what we just started conversations about how we're going to iterate on the storage to make some of these situations better. But what ends up happening is that same thing, right? If you have really long chunks, you're splitting and sharding means that queryers are just going to all have to access. Now, caching alleviates most of this trouble, but it's like you don't gain any parallelization performance, generally speaking, when everybody's accessing the same chunk. Yeah. Well, that's not totally true. I would say 1 or 2 hours is probably fine. And, increasing it more than that's probably not going to gain you a lot in the long run. It's not that big a deal if you flush 6 chunks versus 2, but it's going to be better for querying if you probably keep it at 1 or 2 hours for chunk age.
Yeah, that was my understanding. It's around the what's performing over a gRPC connection to an ingester versus backend stores, and the fact that the backend stores can be cached because those chunks are finished, and the
Absolutely.
ingester is a dynamic chunk. I think the reason I ask on this, because I think it's related to the split queries, but also it'd be communicating the defaults. It's somewhere to look up, whether that's in the Helm charts or somewhere to see what the standards are. I think some of the defaults are non-documented for 2.4. I think they were internal defaults, but if you had a config already where you set them, I think what you had before would be kept with the way that the config set, isn't it?
Yeah, that's good. This discussion has come up in the sort of like a next step, which would be a config auditing tool or something that we would do to answer that question for everybody, right? Already running, like what does because we simplified the config, and in doing so, exactly what you said, we internalized it. We didn't really document it. So I'm sure Karen's, if she's still on the call, ears are burning because she's our tech writer and has been asking us for a long time to help solve some of these problems. Take that as a good note here that if nothing else, we've actually recently talked like what are good reference implementations. Like we've started some work on this. It gets tricky because there's so many ways you can run Loki with so many stores, but some of these configs would be the same regardless. So we could definitely document those.
Steve, can you share a little bit about how you're running Loki? Like, are you running like single binaries per tenant? Are you using the new single scalable deployment model? Are you running microservices?
So we're running the distributed Helm chart backed on S3. We haven't got any memcache caches at the moment because we're running in cluster. So we're talking about most clusters are sort of, I'd say, about 50 nodes. So we're running all of our observability in cluster as a control plane with the potential to then aggregate those in something separate, maybe Grafana Cloud or equivalent outside of it. So not huge setups, but the microservice model, because when we previously ran in single binary, we did see the differences around the around the read write, and really happy with it. I think we used it on some clusters previously. We're just now shipping it to every single one of our clusters with a new pattern, and some of them have different use cases which might where we might not have been called out before running what we had. We're a bit more conscious about the performance, so having the reference to look up, even just knowing to look in that libsonnet file, that will make my life a lot easier.
Yeah, it's like I have an answer for you, not a good one. But this is for the curious DIYer, right? How do we run distributed Loki? What are the configs we use?
Yeah, I mean, though, I guess I would ask first before, like, how correct is that now? Like, because we often override. I'm not sure that we've even upstreamed our own changes entirely.
Yeah, I think it's a lot better than the defaults. We also do, as Ed said, we have another overlay which kind of lives on top of this, the open source one as well, which is kind of tailored to some particulars for how Grafana Cloud specifically does it. And there is definitely some improvements to be made for migrating some of those changes up. But I do think this is right, like, it's immediately here. It is not by no means a good answer. It is an immediate bad answer that can be helpful.
Yeah, throw it in there for sure, just so that people. But yeah, I will say it's very present in our minds to continue improving this. Like, I apologize. It's been we really appreciate how much people have endured figuring out this stuff on their own. It's certainly not how we want to grow the project in the long run by not having these example configs. So we're hopefully going to fix that. I don't know. I feel like you've heard me say this before, though. So anybody's been
you're running out of goodwill, Ed.
I know. But this feedback is really helpful, Steve. Anytime anyone, and it's why it's nice. I'm happy you showed up, because it's both encouraging for us to see use cases and what you're doing, and a good reminder to us that this stuff is really important to get prioritized.
Yeah, it looks like
I think that was it for 2.4 that I was going to talk about. So, and if anybody else had any questions or feedback on their experiences with 2.4, going once, going twice. Nice. Cyril wasn't able to make it, so I'm just going to mention this. It's not released yet, but we did add support for as a UDP receiver for the Graylog extended log format, so that you can ship Graylog Gelf. I don't know if it's pronounced Gelf or Gelf. Say
it sounds like
anyway,
Grafana Enterprise log format.
The Grafana Enterprise. Oh my god, don't confuse anybody. So the Graylog extended log format will be available from UDP, and it's effectively JSON. So after it's received via UDP, you can use the Promtails pipeline stages to manipulate the JSON to pull maybe they call them tags, I can't remember, into labels if you want. But so another cool way to get logs into Loki. And this one, Danny, this is super exciting. I can't wait to see how this one. I wish we had some cool graphs to show, but we haven't promoted it through enough environments yet. I don't think, have we?
No.
Nope. But there is one. If you click on the tempo PR, they show what impact it had on their side. We would probably get larger gains, I would imagine. So yeah, we're really excited to see this happening.
There's also some. Is the tail at scale?
Yeah, I mean,
Yeah.
somewhere
Danny, you
in one
want
of
to
these
sort of describe
PRs?
what it is?
Yeah. So, Owen, if you go to the first PR in the first, or in the, yeah, that one, PR1, that's got the tailored scale paper link in it there. Yeah, so the idea behind this feature, and this was implemented by Cyril, so another item taking credit for Cyril's work this week, this unreleased feature as yet. So when you are fetching chunks from object storage, if your object store is experiencing some latency, that can really push up the latency of the overall query, right? So if you've got a query and that's got to fetch 100 chunks, and one of those chunks is a bit slow to retrieve, that increases the latency of the overall request. So what this change introduces is the ability to hedge a request. So we will, you'll typically run this in your environment for a while, and then figure out what is your sort of P99 of your requests to your object store. And then you can configure this hedge request feature so that when you when a request exceeds that P99 time, it will actually cancel that request and issue a new request. And the idea around that is that if you're using a cloud service, that one request to that one chunk in the object storage could have hit a node that was a little bit overloaded, or there's some other kind of network congestion, and you issue another request, and that usually completes faster. And so there's two pull requests there. The one is implementing the base feature, and the second PR is implementing the rate limiting. And the reason why we need the rate limiting is because if the object storage service as a whole is slow, then you're effectively going to be hedging every single request, and that's going to push up your request latencies quite massively. So yeah, those two features together should provide some pretty awesome gains. So we're going to be running it in our cloud environment over the next few weeks, and experimenting with that and seeing what kind of benefit that gives us. But it gave Tempo quite a good improvement on their side, so we're expecting to see something like that as well.
Do you know what their P99s like where
I
reduced
think
in terms of
I think
percentages or
they
something?
yeah, they configured their hedge time at 500 milliseconds, if I remember correctly.
Okay, so it looks like they brought so P99 is generally your slowest request, right? Your 99th percentiles, and this is what we kind of talk about by the tail. That's the tail of distribution, meaning the slowest of the request that you actually sent out. And it looks like they reduced theirs from about 10 seconds to about 2.5. So it's a factor of 4 there, which is really impressive. And when you think about that, this can function at a bunch of different layers. So it can be like the one request that you send to Loki, for instance, but it can also be that Loki splits and shards and parallelizes one request into 1,000. And maybe the thing that holds up your whole query from returning is, one of those 1,000. And the idea is that we can take this and reduce it by a large factor. And so if you're spending a lot of the time on your queries just waiting for something to happen, waiting for the tail to finish, this is another way to kind of mitigate that. Okay. Sorry, did I just talk over you there, Danny?
I just
No,
like to
no,
leave
no.
that
I
silence to
think
make
you
think
explained
about
it. You explained it a lot better.
It's super fun. I mean, the if you look at Loki's traces, you'll see a pattern, right? Where we limit parallelism to sort of save resources, but that does mean we have to wait for, at some point, every one of, say, the 16 queries that were parallelized at the same time to return. And if one of those is waiting 2 seconds for one chunk, then your query ends up being the sum of the slowest requests. And so by hedging those requests, if you take any of those, say 1 or 2 seconds, and just reissue them and they come back in 500 milliseconds, you've substantially improved your query response time. So that's what our expectation is here, is that this is going to be a huge improvement. So very excited. So does anybody else want to take a stab at explaining the same thing?
I would say I put the paper as a link there. This
Yeah,
is
or go read the really good paper about it.
yeah, yeah.
Send to us
It's one of the better papers that I've read in recent memory. I think it originally comes out of Google. But this isn't the only strategy that they talk about, but it's the one that we've implemented in these sets of PRs. I guess we can continue
let
on.
Trevor talk about himself.
Do you want me to play this?
Exactly.
Play the
Yeah,
video while Trevor talks.
Motion.
Yeah. How do you want me to do this?
Yeah, no, I want to just talk about myself. Oh, and that's what
Okay.
I want.
Go for it.
So yeah, I'm starting to change my career into acting. So I got this video going. It's really excited about it.
So did you play a
No,
role,
but-
or were you just Trevor Whitney?
Yeah.
Trevor Whitney.
Yeah, I played myself, actually. No. So there's so a lot of the work that that I contributed to 2.4 was around the simple scalable model. So these two new targets. I'm not just me. I mean, a lot of people worked on these new targets, the read and the write targets. So I put together a video on getting started with those, and then there's also a Helm chart that's in PR, and I'd love some reviews from the community on that, because I am in the same boat as Ed when it comes to Helm and not feeling like I know what I'm doing when I'm getting in there. So yeah, I love if anyone has tried out these two targets. Love feedback. And yeah, that's it.
Do you want to quickly describe what single scalable SSD does?
It's so we introduced two new targets, a read and a write. So the goal is to provide a deployment topology that sits somewhere in between single binary and full microservices, full distributed. The problem that we've seen with single binary is when there's a problem, it becomes a really big problem. So if you have like if your queryers for example, that will actually take down your ingesters because it's single binary, so all on the same. But we thought that we could maybe get a little bit better at, but then the problem with microservices obviously is just it's complicated, right? There's a lot of moving pieces, and so for people who are maybe just kicking the tires with Loki, or like setting it up for maybe like a smaller load, maybe it's for like a hobby project or something like that. We wanted to find a middle ground between the two where it was simpler to deploy in terms of the topology, but was a little bit more rugged and robust than single binary. And so yeah, that's the simple scalable. It sort of encouraged a lot of other work that I think is going to be really valuable, like the query schedulers having a ring. So now even in single binary mode, the queries can be sharded. And then we also got a little smart with the compactor with a ring, so that the ring determines which instance the compactor would run on, and making sure it only runs once. So I think it's really helping push us in a direction where Loki is just easier to run, which is sort of the end goal. But we don't know how well we've done until people run it that way. So give it a try and let us know what works and doesn't work.
Yeah, the only thing that I would say is that I would say the SSD mode is really actually intended for people that want to run gigabytes or even a couple terabytes a day. Like you can scale it, like you're making a trade-off on complexity versus sort of brutal efficiency that you can get with microservices. So that was the idea, right? Like in a number of cases, most people don't want to know what an index gateway is, or query scheduler, or query front end, or queryers, and even the caching layers. And then we hid all of that inside of these new read and write targets. So it includes in-memory caching, and includes the query scheduler, and actually the single binary does now too. So you get that parallelization. So hopefully it's a way to bridge the gap between starting, small and quickly, and having some scalability to ultimately, if you really want to have the best efficiency and observability, just a full microservices approach. So hopefully we're excited to see that make, adoption, especially non-Kubernetes adoption, much, much easier.
Yeah, and actually the video is non-Kubernetes. So if you
All right, dude, should I just watch it? How long is it?
It's like 20 minutes.
Oh, it's 20
yeah,
minutes?
I mean,
okay, never mind.
Watch it at 2x speed.
It's worth watching. It's great though. You did an awesome job, Trevor. I think
Thank you.
You're a better actor than an engineer. Just.
Uh-oh. I don't know if that's good news.
I don't know either. What
In
Yeah,
public
is
too.
that a burn or a compliment?
I'm not sure either. Let's take it as a compliment.
Yeah. Yeah. Let's segue into Ivana, the 8.3 release. Not dwell on that one.
Save us, Ivana.
Yeah, so basically I just wanted to mention here that yesterday we had 8.3 release that comes with long-awaited and long-wanted feature, which is log volume, or you might know it under the name full-range log histogram. This feature is still under feature toggle, so if you would like to try it out, you need to, in your custom ini file, toggle this feature, and let me find out what's the name. Maybe I should mention it here. So the name is full range logs volume. I will maybe, Owen, you can write it in the doc, or I can write it in the doc.
Yeah, if you could do that, I'd appreciate that.
Okay, so feature toggle.
We'd love feedback on this. We're I would say, like, we're the two big concerns, or there's two sort of questions. One is what the UX is like and how do people like it. In our experience running it, it's nice to have the full range histogram. I know I've said a lot of mean things about it in the past, but it's nice that, most of my arguments have always been, and the concern we have, right, is like, it's a lot more query work, right? When you're doing logs queries, now you're also going to be doing a metric query at the same time. So we've hedged that by limiting it to 10 seconds, which sort of is a way to say, if you're querying a really long time, that it, doesn't consume a huge amount of resources. And this is the part that I think is going to probably be a bit contentious in what that experience looks like. So I'm interested to see. We're going to, run it on our cloud environment. We're going to do sort of a beta version of it first, try to understand what the performance looks like, see if we can be a little bit more lenient with that timeout, see what the experience looks like. But it's very exciting though. Go check it out. You just got to enable that feature flag. I don't know if we can link to an easy way to do that somewhere, but yeah, would love feedback. I don't know, maybe we should create a GitHub issue or something to give feedback.
Yeah, we can either create like one issue, or I was thinking that if anyone has any kind of issue feedback, just like create issue for that specifically in Grafana repo. I'm wondering if it should be Grafana repo or Loki repo, as it's kind of interconnected, but if you do it in any of these repositories, like, we will get the feedback and
definitely the Grafana repo.
Okay.
Yeah, it's a good question. I would say Grafana though, just because we're largely targeting the sort of user experience, and the front end part is what we're looking for feedback. But as an operator, I guess we could have one for Loki too, right? Like, what's your experience like as an operator of a Loki cluster when you turn this feature on? So we could maybe do both and reference each other.
Yeah. And so I'm not sure if anyone has any questions or thoughts, or anything related to log volume that you would like to ask or tell. If not, I have like one more little feature, which is, it's not really like related just to Loki, but in Explore we have introduced this like graph modes, so you can change it from just line to like dots or bars. So if you would prefer different visualization, now you can toggle it out.
All right. I guess we should open this to the floor. If anyone has any other questions, topics you want to bring up, tell us that we're doing a good job, bad job, whatever. And otherwise, we can probably cut this a little bit short and give everyone back some time. All right. Thanks everyone for coming, and we'll see y'all, I guess, in next month. And enjoy the holidays.
Yeah. Thanks, everybody.
Thank you very much.
Everybody.